Welcome to the KSET series. Today I have come up with a question where number of microstates associated with a given configuration is asked. This is from 2016 KSET examination. Now we shall see how we can solve this question. So if we want to solve this question in the proper way, we need to know the formula to work out the number of microstates for any given configuration. So the formula to work out the number of microstates for any given configuration, it is this: n factorial divided by n minus r factorial into r factorial. So in this formula, n and r, they can be decided easily on the basis of given configuration. N, it will be nothing but maximum capacity of the subshell for which they are asking the number of microstates. Similarly, r will be nothing but number of electrons to be filled in the open subshell, or whatever number of electrons they have asked you to fill, so that value you can take it as r. So now if we apply this formula to D2 as well as P3 configuration, so what are the answers that we get, that we shall see. For D2, n value it will be 10 and r value it will be 2. See, it is a D subshell, so therefore n value, that is nothing but maximum capacity of D subshell, that will be is equal to 10. Maximum 10 electrons can be filled in D subshell, so therefore n value it will be 10. And 2 electrons I have asked you to fill D2 configuration it is, so that value D2, that 2 you can directly take it as R here. Now if you just substitute the values into the formula, number of microstates, that will be is equal to n factorial, that is 10 factorial, divided by n minus r, which is nothing but 10 minus 2 factorial, into r factorial, which is nothing but 2 factorial. So if we just expand the factorials, 10 factorial, it will be 10 into 9 into so and so up to 1, and 10 minus 2 factorial, it is nothing but 8 factorial, 8 into 7 into up to 1, and finally 2 factorial. Now if we go for simplification, remember here it is not necessary to work out the whole 10 factorial and similarly whole 8 factorial, so it will be simply waste of time. Instead of that, what we can do is this 8 factorial portion, 8 into 7 into up to 1, so that can be cancelled here and here. So now the equation simplifies to very easy form. This is 10 into 9 in 10 into 9, 8 onwards we have cancelled, which will be equal to 90. 90 divided by 2 into 1, which is nothing but 2. So 90 by 2, the answer it will be 45. So number of microstates for the configuration D2, it will be equal to 45. So just if you look at this portion of the answer, and if you look at the options, in 3 of the options, A, C as well as D, they have given the microstates for D2 as 45 itself. So therefore, just by working out D2 microstates, it's not possible to answer this question correctly. So we may have to even work out the configuration P3 number of microstates. For P3, n value it will be 6, because P maximum capacity, P subshell, it will be 6 electrons and 3 electrons are to be filled here, so therefore R value it will be equal to 3. So now again same thing, we can substitute the values into the same formula, n factorial divided by n minus r factorial into r factorial. So n value it is 6, so 6 factorial, n minus r, which will be nothing but 6 minus 3 into 3 factorial. So now on expansion, again 6 factorial is being expanded, and 6 minus 3 factorial, it is nothing but 3 factorial, that is 3 into 2 into 1, and again 3 factorial, 3 into 2 into 1. Same thing, same story we can do here. 3 into 2 into 1 portion, here and here we can straight away cancel out. So now we are left with 6 into 5 into 4. 6 into 5 is 30, 30 into 4 is 120. So then again divided by 3 into 2 into 1, which is nothing but 6. So it is 120 divided by 6, which is nothing but 20. And if you look at the options now, in the option D, response D, they have given that 20 as the number of microstates for P3 configuration, and even for D2 it is matching 45. So therefore option D, option D, it is the correct answer for this question. So now this is the way in which we solve this question in the traditional way or in the proper way. So of course, in competitive exams it will be very important to get the correct answer, but getting the correct answer in lesser time, that is also more important. So how we can solve this question, the same question, using shortcuts and tricks, that we shall see. So now always it is recommended that you just don't jump into working out the solutions by looking at the STEM portion of the question. So you always have a look at the options given. So if you look here, you can find the options given, and if you read them carefully, you notice that number of microstates for D2, it is given to be 45, 45 and 45 in 3 of the options. So just based on this, you can quickly decide that the number of microstates for D2 it could be 45, right? Or just by working out the number of microstates for D2, you cannot just decide the answer because there are 3 options which contain the same value. But if you look at the other part here, 6, 30, 30 and 20, in just 2 of the options they have given 30. So therefore, if you work out the number of microstates for P3 configuration, there are chances that you may get the answer directly, right? So first we shall work out the number of microstates for P3. Of course, P3 it has come to 20 in the traditional way, but now we shall see how we can do this in a faster way, right? Without using the formula. Of course, it is using the formula itself, but just we are skipping one step. So how we can do that so that we can arrive at the number of microstates quickly, that we shall see. See, n value it is given 6 and r value they have given 3. So we should start from the n value. N value in this case it is 6. So what we do is we can start from n value, that is 6. Then 6 into 5 into 4. So I just write those many values as that of 3. So I hope you are understanding this. N is equal to 6. So I am starting from 6. And then, so 3 values are to be written. R value, whatever they have given, those many digits you should write here, right? So starting from 6, I am writing 3 digits. So that's 6 into 5 into 4. Suppose this value R, it was 2. Say it is P2 configuration. Then I need to write just 6 into 5, only 2 digits. If the value it is, say R is equal to 4, then in that case 6 into 5 into 4 into 3 I should write. So you should start from n value and you should write those many digits as that of r, and then you divide this by the r factorial. R factorial, it is nothing but 3 factorial, 3 into 2 into 1, right? It is the same thing. By doing the formula, we are arriving in this expression bit later stage. Directly we can come to this. So you can just keep these values in mind and you can just write this expression and you can go for simplification. So if you simplify again, 6 into 5 into 4, which is nothing but as we have worked out earlier, it is 120. 120 divided by 6, the answer it will be 20 itself. Now we have just worked out the number of microstates for P3, and if you look at the answer in one of the option D, the number of microstates they are matching, and in no other options this 20 it is available, 36 and 30. So therefore, just by working out the number of P3 microstates for P3 configuration as 20, readily you can decide that option D, that itself is the answer for the question. So the correct answer for this, as we have seen earlier, D itself. So in this way we can arrive at the correct answer in a quicker way. For more such chapter wise and topic wise KSET previous appeared questions, you can refer to these books: KSET in Chemical Sciences, Inorganic Chemistry, similarly KSET in Chemical Sciences, Physical Chemistry. If you want to get your copies, you can contact the number via WhatsApp. You will get the details of purchase. Thank you for watching the video. Thank you.